I will be discussing this topic, um, number system, or for some cases you see it as number base. So number base is a system of numbering. In past time, our great grandfathers usually count numbers in different bases. So you can count as a then there are people who counted in base 2, in base 4, in base 5, and other bases. But currently we count on base 10. We make use of base 10 presently. And so how does this even work? So I'll explain further. I'll explain in depthly in this class. So there are several number bases. If you are counting in base 2, for instance, for base 2, the only two numbers that will be involved are 0 and 1. 0 and 1. So you realize that there are two numbers. These are the numbers that are involved when you are counting in base 2. When you are counting in base 3, you have 0, 1, and 2. This is for base 3. If you are counting in base 4, you have 0, 1, 2, and 3 involved in base 4. So you realize that the amount of numbers you have in them is their base. So for base 2, you have only 0 and 1. They are just 2. Base 3, you have 0 to 2, 0, 1, 2, they are 3. So like that, like that. So if you are to count in base 10, you have the whole of the numbers. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All these numbers are 10. So that this is base 10. And that's the current base we are making use of. So that is the current base we are making use of. Alright, so now, how are we sure about this? I'm going to explain everything. Now, so let's see. So when you are talking about numbers in base 2, numbers that will be in base 2 will only consist of digits like 0 and 1. So you can have it in different form. You can have 1, 0, 1 base 2. You can have 1, 1, 0, 1 base 2. You can have 1, 0 base 2. You can have 1, 0, 0, 1 base 2. So all the kind of combination you will have in base 2 numbers are just 0 and 1. And if you are to work with base 4, for example, you can have any form of numbers that is not beyond 3. 1, 0, 2, 3 base 4. 1, 2, 0, 0 base 4. 1, 0, 0, 2, 3 base 4. So for base 10, you can have every numbers from 0 to 9. You can have 9, 8, 7 base 10. 6, 2, 5 base 10. So the point is, any number, when you are having a number in any base, the numbers you have in that base, each of them are going to be lesser than the base. So if you have something like this, 2, 0, 3 base 3, this would be wrong. 203 base 3 would be very wrong. 203 base 3 will be wrong. So 203 base 3 will be wrong. Reason being that every number in base 3 should be lesser than 3. So this will be wrong. This is not correct to say. So you can also have, if you have something like this, for example, 2, 7, 6 base 5. This is also wrong because you have 6 and 7. 7 is greater than 5, 6 is greater than 5. So there is no number like this. So please take note. The base is always greater than each digit in that makes up the number. So that is one thing. Now, let me quickly flash back to this. For base 10, if you count the numbers we have, there are 10 of them. 0 to 9 are the only numbers you have in base 10. So there are names for each of these bases. Base 1 is called unary. Base 2 is called binary. 3 is called ternary. Base 4 is called quaternary. Base 5 is called quinary. Base 6 is called senary. Base 7 is called septenary. Base 8 is called octal. Base 9 is called nonary. Base 10 is called decimal. Then you have undecimal 11, bidecimal 12, like that, like that, like that, up to hexadecimal. So those are the names for those bases. So please take note of those names. I will drop the names on the comment section. Yeah, so you know how to spell each of them. Alright, so now after learning the introduction to base, numbers can be converted from one base to the other. But before we get to conversion of numbers from one base to another, let me quickly show you the evidence that we are presently counting numbers in base 10. Okay, so take for instance, you are considering 527, 5 to 7 base 10. With our primary school knowledge then, we used to know the place value of 7 here to be units, this to be tens, and this to be hundreds. Now this 5 here means 500. Since it is 100, so it's just 5 times 100 plus this 2 here means 20. How? The t here, remember t here means tens. That is 2 times 10, which is that's 10 in 2 places, 2 times 10. So the same thing here, 100 in 5 places, 5 times 100, 500. So 2 times 10 is 20. Alright, plus. Now, units means 1. Yeah, for some of us who would remember, in social study you were taught unity. They said it's the art of becoming one, oneness. So unity here means 1. Alright, so 1 in 7 places, that's 7 times 1, which is 7. Now, what am I trying to say? This now, remember, as I said, 500 means 5 times 100. This means 2 times 10. And this means 7 times 1. Yeah, that's what this means. Now, you see, each of these numbers that follow them, 100, 10, and 1, can be expressed as a power of 10. How? 5 times 100 is the same thing as 10 raised to power 2. That's 10 times 10 will give you 100. 10 raised to power 2 means 10 times 10, 100. So plus 2 times 10, since this is just 10, it's the same as 10 raised to power 1. 10 raised to power 1 will give you 10. 10 raised to power 1 simply means 10. Then the last part, 7 times. How can we turn 1 to 10 raised to power something? 1 is the same thing as 10 raised to power 0. 10 raised to power 0. So in your year 8, you would have been taught indices or index and indices. Yeah, so here we would have seen that all of them are having tens. So that is why we say that we are currently making use of base 10 numbers. Alright, so I'm going to make one more example, then I'll give you one to try. You can pause the video to see if you'll be right, or better still, let me give you this first. So you can pause the video to see if you can attempt this by now. Alright, so for this one, the place value of 9 is 1000. This is 100. This is tens. This is units. Now, the 1000 here this means 9,000 plus this means 200 plus this means 330. That's 3 times 10, 30. And this means 5 times 1 because unit is 1, 5 times 1. Alright, so now let's split this. This means 9 times 1,000. This means 2 times 100. This means 3 times 10. And lastly, the 5 means 5 times 1 for this part. Now, all these second numbers can be represented as powers of 10. So for this one, this will become 9 times 10 raised to power 3. 9 times 10 raised to power 3. So a way of remembering is how many zeros do you have? So that will be the power. A way of remembering, a trick though. So for this one, 2 times 10 raised to power 2. There are 2 zeros here. For this one, 3 times 10 raised to power. How many zeros? 1. And for the last one, 5 times 10 raised to power. Is there any zero? No. So that you have only 0, 0. So 10 raised to power 0 is same as 1. So this is the expanded form of it. So sometimes you can be given a number that you should put it in the expanded form. A base 10 number, and you ask to put it in expanded form. This is how to go about it. So I just hope you understand it. Alright, so now let's move to conversion of conversion of numbers from one base to the other. Alright, before I proceed with that, there is a pattern you need to notice here. Because this number is in base 10, we have something like 5 times 10. Then the power of 10 was 0. It's only starting with 0 here. Then the next number, 3 times 10. Instead of 0 now, it will be increasing. The power of the 10 will be increasing. 1. The next one, 2. The next one, 3. So that's how it keeps going. Alright. I just hope we understand. So the same thing up here. It was 7 times 10 that came first. 2 times 10 like that. Same thing up there. So now let's see. We'll proceed to conversion of numbers from one base to the other. So that's conversion of numbers from one base or from a base to the other. From a base to the other. So for this one, we are going to start with conversion of numbers from other bases to base 10. Let's start with that one. Conversion of numbers from other bases to base 10. So that will be the first subtopic under this part. Conversion from other bases to base 10. Conversion from other bases to base 10. So for conversion from other bases to base 10, anytime you are dealing with this, I'll give you a format to use. So if A, B, C, D is a base, is in another base that is not base 10, it's in another base that is not base 10, then to convert to base 10, the base 10 form will be given as, take note, you know this is A, B, C, D, base K. That's the main question. Is in under base. The K is not base 10. Where K is not 10. K is not 10. So you will say this A times K plus B times K plus C times K plus the last one, which is D times K. D times K. Now, on top of the base, K is the base, you start putting from the last one, 0, 1, 2, 3. So you realize that it follows the format I just finished. Yeah, this format. It follows this format here. 0, this is the under one. 0, 1, 2. 0, 1, 2, 3. So that is it. So this is what you do. So now let's take examples. Let's say example. This is how to do it, how to solve or convert numbers from other bases that are not base 10 to base 10. So example, convert 2, 3, 4, base 6 to base 10. The second one is number 1. Number 2, convert 409 base 402 base 5 to base to decimal ordinary, that's base 10. So let's solve for the first one. 2, 3, 4 is in base 6, so it means it is in another base, not in base 10. So we are converting it to base 10. So we do 2 times 6 plus 3 times 6 plus 4 times 6. Now remember, on top of the base, which is 6, you'll be putting this. You start with 0 here, 1 and 2. So this means 2 times 6 raised to power 2 means 6 times 6. Please don't make mistake. It's not 6 times 2. What it means is 6 times 6. Then 3 times 6 raised to power 1 is the same thing as 6 plus 4 times 6 raised to power 0. Any number raised to power 0, any number that is not 0 raised to power 0 is 1. Please take notes. Any number like A raised to power 0 is 1, as long as A is not 0. But if A is 0, 0 raised to power 0 cannot be 1. So please take notes. So this will be 2 times 36. 6 times 6 is 36 plus 3 times 6 is 18. 3 times 6 is 18 plus 4 times 1 is 4. So this will be 72 plus 18 plus 4. So that is 94 when you add all of them. So 94 base 10. Don't forget to put the base. 94 base 10. The base 10 will be written as subscript. 94 base 10. So that will take us to the next example, which will be the last one. So last one for this section. So 402 base 5, we are converting to decimal ordinary. That's still base 10. That's the word that describes base 10. So for this we do the same thing. 4 times 5 plus 0 times 5 plus 2 times 5. So on top of the basis, which is 5, we'll be putting 0, 1, 2. So we have 4 times 5 square. 5 square means 5 times 5. Sorry. Plus, if this is 3 here, it would have been 5 times 5 times 5. Do you get? If it is 4 here, it would be 5 times 5 times 5 times 5 in 4 places. So, yeah, 0 times 5. 5 raised to the power 1 is just 5. And then 2 times, I've told you 5 raised to the power 0 is 1. But anything raised to the power 1, if you have a raised to the power 1, a raised to the power 1 is 1. A raised to the power 1 is a, I mean. Any number raised to the power 1 is that number. So 4 times 25 plus 0 times 5 is 0. 0 plus 2 times 1 is 2. So the answer here will be 100 plus 0 plus 2, which is 102 base 10. So that will be the answer for this one. So that is how to convert numbers from one base, from other bases that is not base 10, now to base 10. Alright, so now let's see how to convert from base 10 to another number. Conversion from base 10 to other bases. Alright, so in order to do this, to convert from base 10 to another base that is not base 10, you keep dividing that number by the base you are converting it to. For example, let me take example so you get what I'm saying. Example, convert 92 base 10 to base 5. Convert 345 to base 4. Alright, so let's see. Solution. So for this one, what we do is you draw a straight line downward. Straight line. Draw the straight line downward. So you put the 92 here. 92 base 10. You are converting it to base 5. That means you have to be using 5 here to divide this. Now, you can also have another line if you care. You can have another line here. Another line here. A colon here, another colon here. So this will be the remainder column. Now, what you'll be doing is you are dividing 5 by 92 and you'll be putting your remainder here. So 5 in 9 is 1. It will remain 4. When I put that 4 with 2, that will be 42. So 5 in 42 is 8. And it will remain 2 because 5 times 8 is 40. And I am dividing 42 by 5. So the remainder is 2. So I also use 5 again. 5 in 18 is 3. 3 times 5 is 15. That means it remains 3 for it to be 18. So the remainder here is 3. Now, 5 again. 5 cannot divide 3 this time around. So you write 0 here, meaning it's not possible. And then, since it is not possible, this 3 will still remain back. So that's why this 3 will now come here. Since 5 cannot divide 3 and it is 0, that 3 will still remain. And that's why the 3 will come to the remainder side. So this is the end of your, whenever you get 0 here, this is the end. So 92 base 10 is equal to, you write your answer upward like this. It's the remainder that you're writing that. It's the remainder that is your answer. You write the remainder upward. So that's 332. 332. Then you put your base. What's the base you are converting to? Base 5. So that's how to undo it. Very simple question. That's how to convert from other bases to base, from base 10 to other bases, I mean. So let's see the next example. 3, 4, 5. 3, 4, 5 by 4. Then we put our remainder here. 3, 4, 5 is 10 by 4. Now 4 in 34 is 8. And it will remain 2. 4 in, when I put the 2 before 5, that will be 25. 4 in 25 is 6. And it will remain 1. So the remainder 1 is here. 4 again. 4 in 8 is 2. 4 in 6 is 1. It will remain 2 here. 4 in 21 is 5. And you know 5 times 4 is 20, so it remains 1 for 20 to be 21. So it remains 1. 4 again. 4 in 5, you have, it will remain, 4 in 5 is 1, and it will remain 1 here. Now, 4 again. 4 can no longer divide 1. 4 cannot divide 1. So this will be 0. Now, because 4 cannot divide 1, the 1 will still come here as remainder. So you have the 1 here as remainder. So your answer will be upward like this. You draw the arrow upward. So 3, 4, 5 base 10 is the same as, is equal to 1, 1, 1, 2, 1 base 4. So that's how to approach this kind of question. All right. Now, the last part of this section is how to convert from a base that is not base 10. Conversion from a non-base 10 to non-base 10. Conversion from non-base 10 to non-base 10. That's if you are converting a number that is not in base 10 to another number that is still not in base 10. So you understand what I'm saying now. So let's see example. EXAM. Example. Convert 214 base 6 to base 7. Another example, convert 3, 2, 0 base 7 to base 9. So look at this. Now, the example says from 214. 214 is base 6, is not base 10, and you are still converting to another base again. That base is still not base 10. 320 is in base 7, and you are converting to another base that is 9, and 9 is not still base 10. So the base you are converting from is not base 10. The one you are converting it to is also not base 10. So how do you approach this? This is 2 steps. So in this kind of situation where you are converting from a number that is not base 10, a base that is not base 10, to another base that is still not base 10, there are 2 stages. And we have learned this. We have learned the 2 stages earlier. So the very first step you take is to convert the base or the number. Convert the number to base 10 first. Now the second step is convert that base 10. Convert that base 10 to the required base. Convert the base 10 to the required base. So we are going to see it now. The first example, the solution to the first example, that's 214, 214 base 6. We convert to base 10. How do we convert from another base to base 10? Remember, the first step is convert to base 10. So we are trying to convert this to base 10. The first thing we did, that's 2 times 6 plus 1 times 6 plus 4 times 6. Now you put 0 on this, 1 on this, 2 on this. So you have 2 times 6 square means 6 times 6, not 6 times 2. 6 times 6, and 6 times 6 is 36, plus 1 times, after the 6 times 6 raised to power 1 simply means 6. 6 raised to power 1 simply means 6. That's why this is 6. So 4 times 6 raised to power 0 simply means 1. I have said that before too. So 2 times 36 is 72, plus 6 times 1 is 6, plus 4 times 1 is 4. So this would be 82 base 10. This is the first step, because the first step is to convert the number to base 10. Now, the second step is that base 10 answer, convert that base 10 to the required base. Now, we have gotten base 10, but the required base is base 7. So we need to convert this base 10 answer to base 7. So we have that same, the way we used to convert from base 10 to other bases, remember. So that's what we'll do next. So it's very easy. It's a very simple question or topic. Is 2, 10. Then we are converting to base 7, so we'll be dividing by 7. So 7 in 82 is 11. 7 in 82 is 11. That's because 7 in 8 is 1. It will remain 1. That one, if I put it here, it will be 12. 7 in 12 is 1. And it will remain 5. So the remainder here, you put your remainder up here. The remainder is 5. 7 again. When you use 7 again, you have 7 in 11 is 1. And it will remain 4. 7 again. 7 cannot go in 1 this time around. So it will turn 0. This 1 will now come to the remainder as this. So that means, what's the main question? The main question is 214. 214, I mean, not 214. No. It is called 214 base 6. Because if I call it 214, that means it's already bigger than 6. Of which it can be. So 214 is equal to, what's the final answer? 145 base 7. So this is the solution for the question. That's how to go about it. So let's proceed to the next number, number 2. Please, I want to manage this paper, this book. I don't want to keep opening and opening. So I'll manage this space here for the remaining solution. Please just concentrate on the face I am using, the face of the book that I am using. Alright, so 320 base 7 is the next question. 320 base 7. We will convert 320 base 7 to base 10 first, according to the instruction. So that's 3 times 7 plus 2 times 7 plus 0 times 7. That's 0, 1, 2. So that will give us 3 times 7 square means 7 times 7. 7 raised to power 2 here means 7 times 7. So that's 49 times 2 times 7 raised to power 1 simply means 7 plus 0 times 7 raised to power 1. Yes, 7 raised to power 0 I have said is 1. So 3 times 49 should be 27 plus 120. That's 149. This plus, plus 2 times 7 is 14 plus 0. So this will be 163. 163 base 10. That's not the end. We are not converting to base 10. We are converting to base 9. So we need to divide this. We are converting from base 10 now. This new base 10 that we have gotten, according to the instruction, after we have converted from the main number to base 10, we convert the base 10 to the required one. The required one is base 9. So we have this drawn again. Here we are trying to convert the new answer 163 base 10 to base 9 that is required. To base 9 that is required. So let's see, would use 9 here. 9 in 16 is 1, and it will remain 7. So 9 in 73. 9 in 73 should be so okay. So 9 in 73 should be 8. So it will remain 1 because 9 times 70, sorry, 9 times 8 is 72. So the remainder here is 1. Now 9 here will be 2, remainder 0. 9 again, 9 cannot go in 2 at all, so you have 0, and the 2 will still remain since 9 cannot divide 2 and it has turned 0, so the 2 will remain here. So our final answer, we are going to write the main question 320 base 7 to the remainder, which is always the answer. So 201 is always upward, base what? Base 9, because we are converting to base 9. So this will be the end of this class. I will give you some questions to practice with, convert. All right, so thank you very much. If you have any question, you can ask in the comment section, but you can attempt this for you to be sure that you really understand the topic. So you convert numbers from convert 215 base 7 to base 3. Convert 215 base 7 to base 3. Convert 624 base 8 to base 6. This will be enough. This will be enough, yeah. Thank you very much. Also, you can expand this for me also. Expand this 3024. Give it in the expanded form. Thank you very much. Please, if you are just watching my video for the very first time, kindly watch to your satisfaction. Also, in the process of watching, kindly like, subscribe, and follow. Probably, I don't know where you'll be getting the video from, but follow, subscribe, so that whenever I drop other videos, you can access them. Thank you very much.